Previously, we derived a handful of formulas that can be used to determine probability over an interval in terms of the CDF, the cumulative distribution function. In the example for today, we are limiting ourselves to the discrete setting, in which case the formulas on the screen right now are valid. Later, when you learn about continuous random variables, somewhat different formulas will be needed. So consider the following example. We have some partial information about the CDF of a random variable. At 0.5, it's 0.25. What does that mean? It means the probability that x is less than or equal to a half was about 0.25. Also, the probability that x is less than 0.5 is 20%, and so on. So based on these four values, we will answer the four questions found at the right. To start with, if I am looking for the probability that x is less than a half, that means the same as looking at 0.5 minus. At that point, you have a CDF, and the CDF value was 0.2. On the other hand, if you're looking for x greater than a half, one of the formulas will be needed. In particular, the formula that says take 1 minus the CDF at that value, or 1 minus the probability x is less than or equal to a half. Plugging in from the known CDF, we get an answer that corresponds to 75%. Now, probability over an interval. The probability is between a half and 1. This is one place where you need to be particularly careful because changing those less thans into a less than or equal sign often changes the answer. This one corresponds to the probability x is less than or equal to 1, which is fx at 1, and then you remove everything from a half on down because that is not in the interval. So the CDF value at a half. Plugging in from what we were given here, that's 0.8 minus 0.25, or 55%. Finally, the fourth of the examples here. Looking at a value from a half to 1, the formula highlighted in yellow shows what values of the CDF should be used. Use the upper bound minus and the lower bound with a minus as well. Now looking back at that top equation here, the probability that x is between a and b can also be applied in the strange setting where a and b are the same. In that case, it tells us that the probability that x equals a is found by taking the CDF at a minus the CDF a tiny bit before that. Well, in our data here, there are a few examples where we were given a CDF value and then the CDF value a tiny bit less. So those can be plugged in here. If I want the probability that x is a half, take everything up to a half and remove all the amounts that were a teeny bit less than that. And in this case, that will bring you to 5%.